Okay, we're going to talk about the quadratic formula today. So again, we have examples with some answers worked out and how to type them into WebWork, etc., etc. But let's just come over here. So first of all, where does it get its name quadratic? Well, if you have a polynomial like this, an expression like this, so the a, b, and c are just numbers. And the variable here is x, and the degree is the highest power of x. So this has degree 2, and if it's degree 2, it's called a quadratic. If it has degree 1, it's called linear, because you have the equation of a line. But when we get to degree 2, that is a quadratic equation. Now, if you set the quadratic equation equal to 0, then the solutions to this, so the solutions for x, are called zeros. So you could be asked to solve this, or you could be asked, the same question would be, what are the zeros of x squared minus 8x plus 15? What values of x will make that equation equal to 0? So we haven't learned this formula yet, haven't done anything with it. One way to solve that would be to factor it, if you can. And this one factors pretty easily. Two numbers that multiply together to give you positive 15, but at the same time add up to give you negative 8. And negative 5 and negative 3 will work. Negative 5 times negative 3 is positive 15, and negative 5 plus negative 3 is negative 8. Now, when you have it in factored form, it's easy to see what the solutions are. What happens if x is equal to 5? Well, you'll have 0 times 5 minus 3, which is 2, but 0 times anything is 0. And what if x is equal to 3? It will also make the whole thing equal to 0. So we say that 5 and 3 are the zeros. They're the x values that will make this equation equal to 0. That's where it gets its name. Now that's great if you can factor it. But there's another way you can use what's called the quadratic formula to find the zeros. So if I want to find the zeros, then of course we're a, b, and c are equal to these numbers. So if I'm going to use the quadratic formula to solve this, then we can see that a is going to be equal to the number 1. B is equal to negative 8, not 8, negative 8. And c is equal to 15. So my solutions for x, my zeros of this equation, are going to be negative b. Negative b. B itself is negative 8. Plus or minus the square root of b squared. Now make sure you put this in parentheses, because that is equal to negative 64, whereas that, you're squaring everything, is equal to positive 64. So if you don't use parentheses, you're going to get it wrong. Then minus 4 times a times c all over, now some students will just put the top of the fraction here, all over 2 times a. The negative of negative 8 is positive 8. Then we have plus or minus the square root of negative 8 all squared is positive 64. Minus 4 times 1 times 15. And that's going to be 60. All over 2 times 1, which is 2. 64 minus 60 is 4. And the square root of 4 is 2. And now I have two possible answers. This plus or minus sign means you can either use a plus or you can use a minus sign. So my two possible answers are going to be 8 plus 2 all over 2 or 8 minus 2 all over 2. So this gives 10 over 2, which is 5. And this gives 6 over 2, which is 3. And notice that's exactly the same answer we got when we factored. So if we go to the actual example sheet, we can clearly see that the zeros are 3 and 5 when we factored it. And then when we use the quadratic formula and plug these numbers in, I didn't actually use the plus or minus until I got to the very end there, but either way is fine. So when I was doing this on the paper, I used the plus here and the minus there, which gave us the correct answer. But here, if you have a sum or a difference of numbers in the numerator, you can split that up into 2. So 4 plus or minus 1, so 4 plus 1 is one answer and 4 minus 1 is another answer. Okay. Now, what if you're told to solve that? Well, if you're going to use a quadratic equation, it's got to be in the correct form. So let's just get rid of that. All right. Now I want to solve that. Well, if I'm going to find the zeros, my equation has to equal 0. So the first thing I want to do is put it in the correct form. I need to add x to both sides. So I'm going to have 2x squared minus 36 plus x equals 0. But still, I need to change the order because I need to have the x squared term first, then the x term, then the constant. Now, I could try and factor that, but I don't think the trick works for trying to factor this. So I think it would be quicker if we were going to find the zeros and understand that solving this is the same as solving this. And so I'm going to use the quadratic formula. We can see that A is equal to 2, B is equal to 1, and C is equal to minus 36. So the zeros are going to be x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to have negative 1 plus or minus the square root of 1 minus 4 times 2 times negative 36. Well, these two negative signs cancel. 4 times 2 is 8, and 36 times 8 is 8 times 3 is 24, and 4 more is 28. Okay, so make sure I did that right. So I'm going to double check that. Four times 2 times 36 is 288. So plus 1 is 289. Now, if we're lucky, that's going to be a perfect square. And 2 times 2 is 4. . And I think it's 13 squared, but again, you can always check. I can come here and do second, then the x squared button, and then 288. Oh, sorry, 289. 17. Okay, so, and that was a plus or minus symbol. And so I'm going to split it off into two parts, -1 plus 17 over 4 and -1 minus 17 over 4. -1 plus 17 is 16, and 16 over 4 is 4. So one of the zeros, one of the solutions to this is if x is equal to 4, and that's easy to check. You can plug in 4 and see that both sides give you that. Or I'm going to get -1 minus 17 is -18 over 4. I'm not going to get a whole number there, but 18 is 2 times 9, and 4 is 2 times 2. So the 2's cancel, and I'll get -9/2. Or you can always ask your calculator -18/4 in lowest form. So -18/4, enter, then math, enter, -9/2. So those are my two solutions. Now let's check it with the lab sheet, with the calculation sheet. So here I used the plus symbol and got 4, and here I used the minus symbol and in reduced form -9/2. Okay, so again, let's look at this one and see what we're going to get. Let's solve that one. And let's blow that up so you can see it. Okay, so again, if I'm going to use the quadratic formula, or if I'm going to factor it, I need to get everything all on one side. So what I would do for this one is I would want the right-hand side to be 0. So I'm going to subtract 4 from both sides. And I'm going to subtract 7x from both sides. And so when we do that, we're going to get 0 over here. So we're going to have 9x squared. And then you want them in decreasing powers of x. So 9x squared minus 7x minus 4. That's what I want to solve. So solving this, the original question, is the same as solving this. Now I can try and factor that, or I can use the quadratic formula. And I think something like this, I don't think it will factor nicely. So after the previous lab, that was on ones that had nice results. This will not be factored over integers. It will factor, but it will be horrible fractions. So we can see here A is going to be 9, B is going to be -7, and C is equal to -4. And so if I want to solve this, i.e. find the zeros, what are the solutions for x? It's going to be x is equal to -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So the negative and -7 is +7, plus or minus. -7 all squared is +49. And -4 times 9 times -4, well, the negative signs cancel. 4 times 9 is 36. Or you could do it on your calculator. 4, it's positive. So -4 times 9 times -4 is positive. Okay, 144. All divided by 2 times 9, all divided by 18. Okay. so 144 plus 49. And I'm getting 193 there, I think. Let me see what it says. Okay. Let me come here. So you can see that's exactly what we're getting there. Now the problem here is that 193 is not nice. So here, 289 was a perfect square. 289 is 17 squared, so the square root of 289 was 17, and it was nice. But that's not the case for 193. It is not nice. So there are two answers, and one answer is when you use the positive sign, and the other answer is when you use the minus sign. Now, if you are asked to put this into a web work problem, these are your answers. And in web work, you want to enter these, and you wouldn't actually put the and, you wouldn't write and, you would type a comma to separate them. Okay, so remember, you have more than one term in the numerator. So I'm going to put square brackets around the numerator. I only have one number in the denominator. So inside here I'd have 7 plus the square root of 193. Since we already have parentheses there for 193, that's why I put the square brackets. Okay, so you have to put the entire numerator in parentheses. Okay, so that should sort that one out. Now, the discriminant, when you have the quadratic formula, it's repeated, so given this equation and this quadratic formula, the discriminant is the argument inside the square root. So it's b squared minus 4ac. So if the discriminant is a positive number, you will have two real zeros, which is what we've been having in these examples. We've had two real zeros. Okay, so the solution set would be 5, 3. Solution set here would be 4, negative 9 halves, etc., etc. So if the discriminant is positive, there are two real zeros. If the discriminant is 0, you're only going to get one answer, one solution. If this discriminant is negative, there won't be any real zeros. You will get two non-trivial complex zeros, but we haven't looked at complex numbers yet. So in the previous examples, 2, 3, and 4, they all had positive discriminants, thus they all had two real zeros. Now, what if we want to solve this? So I'm going to copy that. And now let's go over here. Let's solve that either by factoring or using the quadratic formula. Okay. Well, this one is easy to factor. Two numbers that multiply together to give me 9, positive 9, and add up together to give me negative 6. Well, negative 3 and negative 3. So you can see what are the zeros. Well, if x is 3, it makes the whole thing 0, but that 2. So I have 3 as a 0, and it's repeated, but there's only one answer. The answer is 3. That is the solution to that. That is the 0. Now, what if I use the quadratic formula? Well, a is 1, b is equal to negative 6, and c is equal to positive 9. So the zeros are going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. The negative of negative 6 is positive 6. Negative 6 all squared is positive 36. Minus 4 times 1 times 9 minus 36. And so we can see here that the discriminant is 0. b squared minus 4ac is 0. And the square root of 0 is just 0. And of course, 6 plus 0 is 0. 6 minus 0 is 0. And so I only have one solution, and it's 3. Now, if I look at this one, show that that one has no real zeros. Well, a is equal to 1, b is equal to negative 2, and c is equal to 9. So the discriminant is b squared minus 4ac. Which is going to be positive 4 minus 36, which is going to be minus 32. So this says that there are no real zeros. And indeed, if I try and find the zeros using the quadratic formula, I'm going to get minus b, so minus negative 2, plus or minus the square root of negative 32 all over 2 times a. And this is not a real number. Okay, we're going to learn about non-trivial complex numbers in the next lab. All right, so that ends this lab session, and now you should have enough to do your web work problems.